Digital mobile radio has completely transformed the VHF landscape in amateur radio. Originally developed by the European Telecommunications Standard Institute for commercial use like delivery fleets and security teams, hams adopted it because of its spectrum efficiency, clear audio, and the ability to link globally via the internet. Unlike the unpredictable atmospheric magic of 80 meter or 160 meter HF, DMR offers reliable static free communication provided you have access to a repeater or the internet. The defining feature of DMR is the time division multiple access TDMA. Standard analog FM uses 25 kHz or 12.5 kHz channel continuously. DMR takes a 12.5 kHz channel and slices it into two rapidly alternating time slots, TS1 and TS2, lasting about 30 milliseconds each. The benefit? Two completely independent conversations can happen on the exact same frequency at the exact same time without interfering with each other. It effectively doubles the capacity of a single repeater. Transitioning to DMR requires learning a new set of norms. Programming a DMR radio is very different from simply dialing in a VFO frequency. Code plug. This is the master configuration file you build on your computer and upload to the radio. It contains all your frequencies, contacts, and settings. Talk groups. Think of these as virtual chat rooms. Instead of calling CQ to whoever is listening on a frequency, you transmit to a specific talk group. Example, TG91 for worldwide or TG404 for India. Anyone monitoring that talk group will hear you regardless of what frequency their local repeater is on. Color codes. This is the digital equivalent of an analog CTCSS or PL tone. It acts as a digital lock. Your radio's color code must match the repeater's color code, usually CC1, to access it. Zones. Because you have thousands of talk groups and channels, radios organize them into zones like folders to make navigating the menus on a handheld radio manageable. DMR repeaters and hotspots don't exist in isolation. They are tied together by massive internet backbones. Brandmeister, the largest and most popular decentralized amateur DMR network globally. It hosts thousands of talk groups. TGIF, another popular rapidly growing network known for being very maker-friendly and flexible. DMR MARC, one of the original highly structured networks, though somewhat eclipsed by Brandmeister flexibility today. If you don't have a local DMR repeater nearby, the most common solution is an MMDVM, multi-mode digital voice modem hotspot. A hotspot is essentially a personalized micro repeater for your house. It consists of a tiny radio hat. Hat is hardware attached on top, attached to a single board computer, very often a Raspberry Pi running software like Pi-Star or WPST. You connect your handheld radio to the hotspot via RF, and the Pi bridges that RF signal to the Brandmeister network via your home Wi-Fi. For hams who already enjoy homebrewing and tinkering with Raspberry Pi based digital setups, building and configuring a hotspot is a highly rewarding weekend project. The good part is global reach. You can talk to someone in Japan, Germany, or the US through a handheld radio using 1 watt power. Battery life. Because the radio is only transmitting for half the time due to TDMA slicing, battery life on DMR handsets is phenomenal. Audio quality. Digital error correction means there is no static. You either hear the person perfectly clearly or you don't hear them at all, the digital cliff. The catch. The learning curve. Building your first code plug can be highly frustrating. It requires understanding how time slots, stock groups, and contacts all link together. Internet dependency. If the internet goes down, the global aspect of DMR dies with it. It does not replace the self reliance of a good HF setup.